August 1, 2012. Knight Capital Group, one of the largest market makers on Wall Street, pushes a software update to production. Within 45 minutes, their automated trading system executes millions of erroneous orders, hemorrhaging $440 million. By end of day, the firm effectively ceases to exist. The root cause is shockingly simple: they deployed buggy code to all 8 production servers simultaneously, with no staged rollout and no fast way back. This single event rewrites the deployment playbook for the entire software industry. The lesson is not about the code quality, it is about how you deploy. Every time your team ships code to production, 3 forces are in tension. First, your users expect zero downtime, they do not care about your release schedule. Second, when something goes wrong, you need to undo the change in seconds, not hours. Third, you want to limit the blast radius, expose the new code to as small a surface as possible before committing fully. These 3 goals, zero downtime, fast rollback, and risk reduction, are what deployment strategies are designed to solve. The software industry has converged on 3 dominant patterns: blue-green, rolling, and canary. Each makes a different trade-off, and choosing the right one for your context is a core engineering skill. Blue-green deployment is the most conceptually elegant of the 3 strategies. You maintain 2 identical production environments, call them blue and green. At any moment, only one is live and receiving real user traffic. When you are ready to release, you deploy the new version to the idle environment, run your smoke tests against it in complete isolation, and then flip the router. Traffic switches instantly. The old environment stays warm, it is your escape hatch. Rollback is not a procedure, it is a single DNS change or load balancer update. This is why GitHub uses blue-green to deploy GitHub.com itself, because when something serving 100 million developers breaks, you want to fix it in under a minute. Visualize it like 2 identical houses. Before the release, the router points to the blue house, every user request lands there. The greenhouse is dark, receiving no traffic. Your CI pipeline deploys version 2 into the greenhouse, runs health checks, and gives you a thumbs up. You flip the router. Now every user request lands in green. Blue is still running, fully functional, serving nobody. If a critical bug surfaces 5 minutes after the flip, you flip the router back. The migration is complete in milliseconds, and your users experience no interruption. This is the power of the atomic switch. The transition happens at the routing layer, not on the application servers. Blue-green is not without its costs. The primary advantage is speed of rollback, it is measured in seconds, not minutes. The secondary advantage is confidence, you test the exact production environment before it receives a single real request. But running 2 full production environments means you are paying twice for compute, storage, and networking. That is acceptable for a well-funded company deploying a critical service, but it is a heavy tax for a startup or a cost-sensitive team. The deeper challenge is database migrations. Both the blue and green versions must be compatible with the same database schema during the transition window, which forces you into multi-phase migration patterns. This is where blue-green deployments require the most architectural discipline. Rolling deployment solves the cost problem of blue-green by reusing your existing infrastructure. Instead of maintaining a shadow environment, you update your servers in batches, one at a time, or a few at a time. Take server 1 offline, update it to version 2, bring it back into the pool, confirm it is healthy, then move to server 2. The key insight is that at every step, the remaining old servers continue serving traffic. Users see no interruption. This is the default deployment strategy in Kubernetes. When you update a deployment manifest, the control plane automatically performs a rolling update, cycling through pods while maintaining your specified minimum availability. It costs you nothing extra. Rolling deployments excel at gradual risk exposure. If your new version has a bug, it surfaces on one server before it poisons the entire fleet. You detect it early and stop the rollout. The trade-off is that rollback is slow. You must re-update every already migrated server back to version 1, which takes the same amount of time as the original deployment. There is also a window, potentially a long one, where version 1 and version 2 are simultaneously handling production requests. This is called the mixed version window, and it demands strict API backwards compatibility. Any breaking change between V1 and V2 will cause errors during this overlap period. Rolling deployments reward teams that practice disciplined, backwards compatible API evolution. The name comes from the mining industry. Before sending workers into a potentially toxic shaft, miners sent a canary in first. If the canary survived, the air was safe. If not, the miners knew before committing. Canary deployment applies this logic to software releases. You deploy the new version alongside the old, but route only a small percentage, say 5%, of live user traffic to it. You watch your dashboards, error rates, response latency, conversion metrics. If everything looks healthy, you gradually increase the percentage, 5 to 25, to 50, to 100. If metrics degrade at any stage, you pull the canary back instantly. Only 5% of your users were ever exposed. Netflix, Google, and Facebook have all built their deployment platforms around this principle. Picture a load balancer with weighted routing rules. 95% of requests flow to your stable version 1 fleet, the same servers that have been running reliably for weeks. 5% of requests are quietly redirected to a small version 2 Canary fleet. Users in the 5% bucket interact with the new code exactly as they would in full production. No mocks, no staging quirks, no synthetic traffic. Your observability stack watches both populations simultaneously. When you confirm the Canary is healthy, 0 increase in error rate, latency within bounds, business KPI stable, you update the routing weights. The Canary grows. The stable fleet shrinks. Eventually the Canary becomes the new stable. The promotion is data-driven, not faith-driven. Canary's greatest strength is its basis in reality. Staging environments are approximations of production, they lack the real traffic patterns, the real data distribution, the real user behavior that causes subtle bugs to surface. Canary validation uses actual production traffic, making it the most rigorous form of deployment testing available. The cost of this rigor is operational complexity. You need a load balancer or service mesh capable of percentage-based traffic splitting. You need an observability stack, Prometheus, Datadog, or equivalent, that gives you real-time signal on both the Canary and stable populations. And Canary deployments are slow by design. A cautious Canary rollout across a critical service might take hours or even days to reach 100%. That is a feature, not a bug. Let us put all three strategies side by side. Blue-green wins on rollback speed, it is instant, a single router change. Rolling wins on infrastructure cost, you reuse what you have. Canary wins on risk minimization, only a fraction of users are ever exposed to unvalidated code. For complexity, rolling is the simplest, blue-green is medium, and Canary is the most demanding. All three achieve zero downtime when implemented correctly. The decision framework is straightforward. If you need instant rollback and can afford 2 environments, choose blue-green. If you are on Kubernetes and cost-sensitive, rolling is your default. If you have high traffic volume and strong observability, Canary gives you the best safety guarantee. Many mature teams combine strategies, using rolling for microservices and Canary for high-stakes user-facing features. GitHub Actions provides the building blocks for all three strategies without requiring external tooling. For blue-green, you define 2 named environments, blue and green, and use environment protection rules to control which one is live. After deploying to the idle environment and running smoke tests, a final job updates the live environment URL to complete the flip. For rolling deployments, the matrix strategy is your tool. Define your server targets as matrix entries, set max parallel to 1 or 2, and include a health check step that gates the next batch. For Canary, the environment feature combined with required reviewers gives you human-gated promotion stages. Each promotion step requires an explicit approval before the workflow continues to increase traffic weight. Netflix pioneered automated Canary analysis through their open-source Spinnaker platform. Their system compares metric baselines between Canary and stable populations and makes a pass-or-fail judgment without human intervention, enabling hundreds of deployments per day with no deployment team standing by. Kubernetes made rolling deployment the universal default in the container era. Every engineer who uses kubectl apply is implicitly using rolling strategy, whether they know it or not. GitHub chose blue-green for GitHub.com itself precisely because their tolerance for downtime is near zero and the instant rollback capability is non-negotiable when 100 million developers depend on the platform. The right choice depends on your traffic volume, your infrastructure budget, your observability maturity, and how fast you need to recover when things go wrong. Let us test your understanding with a scenario. A company is launching a new payment processing service. They require zero downtime during every release. They need to be able to roll back within seconds if a critical bug is discovered post-deployment. Their engineering team has budget approval to run duplicate infrastructure for this service given its business criticality. Think carefully about what each strategy offers. Rolling gives you gradual risk exposure but slow rollback. Canary gives you real user validation but complex routing. Blue-green gives you the instant router flip and the warm standby environment, perfectly matching both the zero downtime and instant rollback requirements. Select the answer that fits these constraints exactly.